Welcome back, everybody. Mr. Reniker here once again, and in today's lesson, we are going to move on to talk about something called the product of powers property. This will be new for many of us, so make sure you have a pencil and paper handy. And of course, feel free to pause the video as often as you need to make sure that you get to copy things down into your notes. Our objectives for today are going to be ultimately to simplify expressions, but we're going to simplify expressions using three different versions of these properties. We have the product of powers property. We have what's called the power of a power property. And then, of course, lastly, we have the power of a product property. So lots of similar names. I'm going to ask you to focus not only on their names, but also how they work. So we'll jump into our first key idea here. So here are descriptions of our three properties, that we'll be using here. And we'll start with the product of powers properties. It says to multiply powers with the same base, all we need to do is add their exponents. And it makes most sense, I think, when you look here at the numbers. If we had 4 squared times 4 thirds. So again, we are multiplying powers that have the same base. They both have a base of 4. What we're going to do is add their exponents. You can see the exponent of 2 and the exponent of 3. And to simplify this, we can just take that 2 and 3 and add them together. And of course, 2 plus 3 gives us 5. So 4 squared times 4 cubed is actually 4 to the 5th power. So algebraically, again, all we do is we take the exponents like m and like n and add them together as long as the bases are the same. Next, we talk about power of a power property. So to find the power of a power, this time instead of adding the exponents, we're going to multiply the exponents. Here's what that looks like. If we had 4 to the 6th power raised to the 3rd power, we would take that first exponent, 6, and multiply it by the exponent that it is being raised to. So 6 times 3 gives us 18. So 4 to the 6th to the 3rd power is 4 to the 18th power. Now that one might take a little bit more thought. Why does that one actually work out that it needs to be multiplied? So keep in mind that the exponent here, the 3, says to take whatever the base is times itself that many times. But here the base is actually 4 to the 6th power. So we have 4 to the 6th times 4 to the 6th times 4 to the 6th. And when you look at it in that way, it's actually able to be evaluated using the product of powers property, meaning we would add the exponents. We would take 6 plus 6 plus 6 more, and that would still give us 4 to the 18th power. So multiplying those exponents from the beginning is just a faster or more efficient way, at least, to evaluate that. The last thing that you'll use today is the power of a product property. So it says to find the power of a product, we're going to find the power of each factor. So you see here with the numbers, it says we have 3 times 2, which is acting like the base because it's in parentheses, to the 5th power. But what we get to do in a way is actually distribute that exponent to each of the factors inside, the 3 and the 2. So to simplify it, we would have 3 to the 5th power and 2 to the 5th power, and they'd still be multiplied together. So if you're taking the power of a product, meaning taking the power of more than one thing being multiplied together, we just make sure that that exponent gets distributed to everything else. Let's go ahead and take a look at these in some examples. We'll start off with some a product of powers type problems. So we have the same base and we are multiplying these powers together. We have 2 to the 4th times 2 to the 5th first, which can be evaluated by doing 2 to the 4th plus 5th, or in other words, 2 to the 9th power. They are going to ask you to leave it as a power, meaning leave it with an exponent attached to a base. If they want you to get the actual value at all later on, the directions will be slightly different. For part B, we would take negative 5 times negative 5 to the 6th power. This one looks a little bit odd because I thought we were supposed to add exponents together, but where's the exponent here? And this is why it's important to remember that every base, whether it's 1, 2, 5, 10, x, or anything else, so if we used x, every base always has an exponent, but it's just not always necessary to write one. If we raise any base to a power of 1, it's equal to itself. So there's like an invisible exponent of 1 there all the time. So when we go to evaluate part B, it's really negative 5 to the first power, then plus the sixth power, since the bases were the same. I should keep parentheses here, I apologize. We add the exponents. 1 plus 6 is 7, so we do have the power of negative 5 to the 7th power. In our next examples, though, we are going to have some power of a power property examples here. And of course, remember here that when we're taking the power of a power, so an exponent raised to another exponent, we actually need to multiply these powers together this time. So 3 to the 4th to the 3rd power can actually be simplified by simply taking 3 to the 4th times 3rd power, which would be the same as saying 3 to the 12th power. Whether the base is a variable or anything else won't really matter. We're still going to take the power of a power, and we're going to multiply them, the exponents together. So we get w to the 5th times 4th power. And of course, 5 times 4 is 20, so we'd end up with w to the 20th power. So far, all that we really had to apply here is whether we're adding the exponents or multiplying the exponents. So it can be fairly basic, but it is up to you to really put together some effort, some organization into how are you going to remember when these properties apply. But we'll add in the last property before we let you try some on your own to see how that's working out. So here in our last example, we're going to go ahead and take a look at finding the power of a product. So remember that if you have a product just meaning that two things are being multiplied together. Here it's 2 times x, and part B it's 3 times x times y. So we just need to make sure that that exponent here gets distributed to all of the factors inside here. So we do end up with, for part A, 2 to the power of 3 times x to the power of 3. The difference in this situation is that if you have a numerical value raised to an exponent that can be evaluated, Big Ideas is going to expect you to go ahead and simplify that here. Meaning we would have to find out what is 2 times 2 times 2. And of course, that's 8 times x to the 3rd power. And x to the 3rd power cannot be simplified, so we'd simply leave that as 8x to the 3rd power. In part B, we'll do the same thing. We'll go ahead and distribute that variable. So we'd have 3 to the 2nd power times x to the 2nd power times y to the 2nd power. This product here, again, the exponent gets attached to each one of the factors. And then we simplify if possible, and it is because 3 to the 2nd power is just 9, times x squared, because x squared cannot be simplified, and then y squared, and the same reason here. So to wrap up those ideas again, in the first scenario, you'll be adding the exponents. In the second scenario, you'll be multiplying the exponents. And then finally, in this last example, you will be distributing the exponents and simplifying as possible. I'm going to give you a set of on your own questions that has kind of all of these mixed in so that you can try them on your own, start to make some of those decisions. And hopefully that'll give you a little bit of confidence before you get started on your own assignment. Let's take a look at those first. So here I have 9 problems for you to try on your own. If you'd like to check your own understanding, you guys know the drill. Please go ahead and pause the video. Take as much time as you need. And as soon as you're ready, unpause the video, but be ready. When you do, I will have all 9 solutions up here for you. All right, here you go. And I apologize. I did have to try to squeeze a couple of them in. Let's go through these pretty quickly. Number 1, you should have had 6 to the 6th power. Number 2 was negative 1/2 to the 9th power. Number 3 should just be z to the 13th power. Number 4 was 4 to the 12th power. Number 5 should have been y to the 8th power. Number 6 was negative 4 to the 6th power. Number 7 was 625 y to the 4th power. Number 8 is a to the 5th power, b to the 5th power. And last but not least, number 9 is 0.25 m squared n squared. And that should be all there is to it. Of course, if you guys had a bit of difficulty with this or would like to otherwise check in with me first, please reach out to me via email. Otherwise, I think we've hit all of our objectives. We've simplified quite a few expressions. We used the product of powers property Here first, we use the power of a power property where we multiply them, and we use the power of a product property where we distribute the exponents. Good luck on your assignment with that part, guys, and as always, I'll see you next time.